Thanks for joining, everyone. Hope you are having a great SC17 so far. All right, so let me start by introducing Cavium. So does anybody know in the audience what does Cavium do? All right, I see few people saying yes. All right, so Cavium is a semiconductor company. We are fabless, and we are a provider of highly intelligent solutions for data centers. We primarily focus on enterprise, mobile infrastructure, data center and solutions, service provider cloud. We have been around since 2001, IPO'd in 2007, and we have been a creator of disruptive technology for the past 17 years. So some of the products we have, so we mainly serve the data center and the enterprise. We have Nitrox security and FIPS adapter, liquid security, ThunderX and ThunderX2, which I'm going to talk more about today. So that is our ARM-based server solutions, data mainly for the cloud and the data center and HPC. Then we have the networking adapters from QLogic and LiquidIO. And we have the explained switch, which is the top of the rack that goes into the spine and top of the rack, capable of 3.2 terabyte switching, and it's fully programmable. So let me start by talking a little more about ARM and Cavium partnership. So as everybody know, what does ARM do? So ARM is in everywhere. It is in cell phones, wearables, IoT, tablets, and they have a very unique licensing model. So they license out their cores as well as they license out their ISAs. So Cavium is an architecture licensee of the 64-bit ARM architecture, and what we do is our team takes this ISA and we develop a custom core ground up. And our current generation ThunderX2, which I'm going to talk more about, it is for HPC and cloud, and it is very good high-performing chip for the server, cloud, and data centers. So some of the notable PRs we had at SC17. The first one is HPE launching their Apollo 70 based on ThunderX2, which is our CPU. Cray announced their XC50 platform, which is a supercomputer based on ThunderX2. Then Gigabyte and Foxconn also announced the production availability of their platform. So the next platform covered the ARM HPC forum, and they showed good benchmarking performance in the article. So please make sure you read the article from the next platform. From the partner standpoint, we had Red Hat announcing the support for Enterprise Linux, and SUSE has also announced the support for Enterprise Linux on ThunderX2, and Microsemi announcing their Adaptec Smart Solution Adapter solution on ThunderX2. So let me take a step back and talk a little more about how we started. So in 2014, okay. Yeah, this will happen. Give me one sec. Yeah.
Is it not working?
No, sorry about it. All right. So let me take a step back and talk a little more about ThunderX. So in 2014, we started with our first. It is going to happen. That's fine. We started with our first ever. We came out with our first ever ThunderX CPU. It was the world's first dual socket ARM server, and we gained significant momentum with a lot of partners offering systems based on ThunderX. Also, we saw a lot of customers adopting to ThunderX. Now, with the continuing of the same momentum, we came out with our ThunderX2. And one of the key things with ThunderX2 was great performance between ThunderX and ThunderX2. We got somewhere around 2x to 3x better performance. And what this translated to, the momentum we started with ThunderX, we saw the same customers adopting ThunderX2, and a lot of partners started offering systems, and we got a lot of good benchmarking data with early customers adopting ThunderX2 silicon. And as a result of that, we have HP, Cray, Penguin Computing having a solution, a HPC solution based on ThunderX2. Let me talk a little more about what is ThunderX2. So as I told you, we are architecture licensee. We have up to 32 cores of custom ARMv8 point 8.1 core, and it's fully out of order. Our CPU is capable of single socket and dual socket configuration, and what this does is you get up to 64 cores in a single node, which is a dual socket. The biggest differentiator of ThunderX2 is we have 8 memory controllers. So for your memory intensive and in-memory workloads, this helps you tremendously, because what 8 memory controllers do in 2D PC, you can get up to 16 DIMMs, which gives you 33% additional memory bandwidth and capacity. Moreover, we have a lot of integrated I/O, and that gives you flexibility to attach a lot of PCI devices and other stuff without needing a switch. And also we have extensive power management capability. So overall, this chip delivers 2x to 3x performance versus our previous generation. So this is some of the value propositions I already talked about. So we have a higher number of cores and threads versus the current HPC processors in the market. We have higher memory bandwidth, capacity. We are the only ARM right now to have the dual socket support, and we have very rich I/O connectivity. So some of the HPC use case that our team is working on is highlighted here. So we have weather forecasting such as WRF, then computational fluid dynamics such as OpenFOAM. So our team is taking these applications. We are working with ARM as well as other partners in order to make sure that it works on ARM. All the libraries, the dependent libraries, the required compilers, everything is optimized, and we get a good performance out of this. Also, we have biological sciences, geosciences application. We have a lot of government labs adopting this. And as you might have seen on the momentum slide I showed earlier, we have a lot of government entities, government labs interested, and they are our early adopters. And lastly, I would also like to highlight that we have ISVs such as Cadence starting to provide support for ARM-based products. So Cadence, a couple of weeks back, they announced their support for Exascale, which is their PCI emulator meant for chip designs, and it works great on ARM, especially ThunderX2. So this is some of the early applications that we are working on, and this is just the beginning. So talking about the OEM providers, so we have HPE announcing the Apollo 70 yesterday. So that is again a HPC system. We have Atos, who has announced the support for ThunderX2 based Sequana blade, and it is a matter of fact used in Mobla project by BSC, and this was announced in ISC this year. We had Penguin Computing, who has announced support for ThunderX2 based systems in the Tundra Extremescale family, and also this happened in ISC 2017 this year. Also Cray yesterday announced the support for XC50 based supercomputers, as I talked earlier. So these are the key OEMs, the who's who we are working with in order to enable customers use ThunderX2 in their HPC systems. Talking about the ecosystem, and this is where we closely work with our partners such as SUSE. So let me take a step back and talk a little bit about the IHVs. So we have a lot of IHVs, especially like Mellanox for the interconnect, InfiniBand-based interconnect for the Ethernet. Then we have the memory guys, the DIMMs, the DDRs, the hard drives, PCI adapters, HBA guys. So we are working with the who's who here. From the OS perspective, we have support for Red Hat, SUSE, Canonical. From the commercial OS side, we have CentOS supported with our ThunderX2, which is community OS. Then from the platform management perspective, we have AMI, who provides support for BIOS and BMC. That makes our ThunderX2 based systems very similar to the current systems available in the market. So the look and feel, if you take a ThunderX2 based system, and if we do not tell you that, hey, what instruction set is being used, you will never realize whether you are using ARM or x86. So that's the level of maturity we are seeing due to all the work the partners such as SUSE has put in enabling the ecosystem with ARM. From the tools and devices, all the vendors such as Altair, Rogwave, Slurm, Bright Computing, IBM Spectrum, and the OpenMPI, they work great on ARM. They have already announced the support for all their products based on ARM. And not only that, we have the compilers, such as the open source compilers such as GNU and LLVMs providing the support for C, C++, Fortran, and as a matter of fact, ARM has taken it up to them to provide ARM Alinea Studio, which is a set of compilers, debugger, profile and reports and performance libraries. And they are providing commercial support for all of this. So that includes the Clang, Flang, and everything else. From the software stack perspective, we have support for OpenHPC and applications as listed here. These are some of the initial applications that we have tested and we are getting things running, but more is in the pipeline. So as this is talking more about the ARM providing the commercial support as I talk. So this is it. And one last thing I would like to highlight is the memory differentiation. Our CPU in a single socket provides up to 132 Gbps of performance, which is highest in the market, and this is really helpful. So what I would encourage everybody is to stop by Cavium booth or one of our partner booths such as HPE or Cray booth and talk more, understand more about what they are doing with ThunderX2. We also have ARM booth where we have more of our systems, and we are looking forward having you evaluate and deploy systems based on ARM. Thank you.
All right, let's give it up for Varun. All right, thanks a lot. That was great. Thank you for coming to our booth and doing that for us. Hang on just a sec, don't leave yet. If people have questions, can they come up and talk to you for a minute?
Absolutely, I'm here.
Okay. Do you guys have a booth here? Did you already tell them?
394.
394.